see how this goes. It's kind of stressful. So I'm a system designer on Hive. This talk is actually a little bit about the non-system designer things and slightly more programmer-y things that I've been doing, but it's all based around system design. So,
do you need me to hold you the mic? I can do that.
Yeah, it's okay. Okay, so this is basically a tools talk, kind of a show and tell. It's largely inspired by Bret Victor's talk, Inventing on Principle. If you guys haven't seen this talk yet, you should, because it's amazing. Yeah. The core concept of his talk is that as an inventor, you should pick a laser focus, a clear principle to guide your inventions, and then kind of fix everything that you find that violates that principle. That part of it is definitely inspiring, but even more inspiring to me was the part where he describes his principle and how he solves the various problems that he runs across. And put simply, that is to bring the iteration time of any digital artist with their art to 0, because by doing so, you get kind of magical discovery. And to dig into that a little bit, we frequently talk about art kind of taking on a life of its own. If you're writing a story, your story might take a turn you didn't expect. If you're working on a painting or a sculpture, suddenly your piece starts to make sense in a direction that you didn't originally conceive of. And anyone really who has made art has this experience. Your art kind of emerges on its own, different from the way you originally conceived it. Why? Because you're engaged in a real-time, iterative feedback loop with your art. Any accidental or subtle change you make suggests other forms about which you weren't originally thinking. So you're working on a sculpture, you move an arm to work on a rib, and suddenly you discover a dramatic pose. And we see some of this in game design, at least at a macro level. These two games each started out very different than how they ended up. Halo was an RTS. BioShock was apparently a tropical island filled with Nazis. But designers still don't experience that same kind of continual emergence that other artists do. And that's one of the greatest ironies of this industry. We work on real-time interactive games, but the tools we use to make those games are often anything but real-time. We can have WYSIWYG editors now, and things are much better, but fundamentally, at least as system designers, we're left using spreadsheets and text editors. And the systems that we work with are complex. So this is a collaboration graph generated by a tool called Doxygen on the Hive code base. And all it's doing is representing the weapon class, which is this little gray box there, and all the other objects that it interacts with in the editor, in the engine. So that's pretty complicated. And as you can imagine, this ends up becoming a multi-dimensional game of dominoes for system designers. If you change one thing, you get unexpected effects all over the engine. And our iteration time is kind of slow. We make a change, you start the engine, you wait for it to start, you play it. So to compare tuning values, you actually have to remember what happened a couple of minutes ago and how the game played. But really, sculpting these systems should be like any other art form. It should be real-time, analog, and artistic. And the interaction needs to be immediate so that we can get those same kinds of artistic discoveries that you find in other disciplines. And this is where I rest for. So this talk by Jamie Griesemer describes a really subtle change in Halo 3, just tweaking the tuning of a sniper rifle and how that led to a pretty dramatic change in gameplay. And it makes you wonder, if a dramatic change in gameplay was waiting for him in that range, what kind of changes are waiting for us in ranges that we can't fully explore? So I think that we should look to some other artists in other disciplines for a little bit of inspiration. Background artists get Wacom tablets, audio engineers get these awesome mixer boards, animation gets motion capture. And these tools are all designed around taking their art out of the beige box and bringing it into tactile, interactive reality. And I imagine that there's a mountain of tools waiting to be developed for designers. And I think there's two major domains that are begging for them. These are modeling and tuning. Modeling is where we have endless meetings and talk about the systems and what they should be. And tuning is where we get involved in balancing the systems once they're already in the engine. So these next couple slides are things that I've built since watching Bret Victor's talk. This first one is a modeling tool. It's kind of Excel with slider controls. You define data points and modifiers, and you define your axes as kind of mathematical interactions of all those different data points. So it's kind of like Excel, but it runs at 60 frames a second. So you can tweak in analog, in real time, your model. You can start fucking with the numbers. And the first thing that I noticed when I was doing this was how quickly I started just playing around with the numbers and trying out things in weird ways. And I started to develop an almost physical understanding of kind of how the model worked. So anyway, that's modeling. Let's consider tuning. So once the modeling is done, you need to get your system in the game so that you can start playing around with it and discover those magical values like Jamie discovered in his talk. And then I wait for a little bit again. Just I'm good. So at some point I had a task to fix a spline camera in some level. The tools we have for working with our spline Cineractive cameras were a little clunky, so I took a little extra time and put together a real-time editing tool. And it's pretty simple and intuitive. You basically just grab the spline actors in the editor, and you see it updated in real time in Pi. And again, the first thing I did when I put this in was I just started playing with it. And I started trying out all these weird, radical camera angles that I never would have thought of trying because the cost of trying them was so high. And at the very least, it made fixing that one bug with the guy staying in frame a lot less tedious. So anyway, back to those cool hardware boxes that other disciplines get. So this next idea is inspired by a stray comment by Fred when he saw my modeling program, and so it's like one part cool, one part crazy. I haven't built it yet, but I don't think it would be super hard. And it's all kind of centered around the idea of those programmable MIDI controllers that audio engineers get. So I think we could get something like this. I think we could bind it to the Unreal editor. I think that we could assign tuning parameters to each of those knobs, and if we're feeling really ambitious, maybe we can actually have it talk over a socket to a dev kit so that you can tune the game while someone else is playing it live. And I think that would be great. And so I think the funniest part about that idea is that if you look at these absurd public conceptions about how game design is conceived to work, these might actually turn out to be prophetic and not just
That's it. The video you had of you using the modeling tool?
Yeah.
It was on an iPad?
It's on my iPad.
Okay.
Right here. Yeah, so it's just interactions with. I was using it to do when we were playing around with modeling our weapon system and making it more systemic. Some of the stuff I was working with Matthew.
This is amazing. Helping you out.
Yeah. Yeah. Do you need any help with the hardware?
Yeah. Yes.
Get some people on that.
Go. Make that a project.
I have a question. Yes.
So having seen large numbers of people on Far Cry 2, right?
Yep.
A lot of people, a lot of artists had to transition from very traditional tools to very analog, messy tools just because of the way the engine worked.
Yep.
There's a lot of paint, like you can't place tree, you can't
Right.
place grass, you got to paint it all in, and it's impacted by the color of the terrain that it's
Right.
on. It inherits properties into the bushes, for example.
Sure.
Right. So it was very much like working with paint instead of working with a modeling program. Essentially, it was a stone wall for 20% of the people who had to make that transition.
Sure.
It's just really hard for them. So, like while I agree with you, what are your thoughts on holding the hands of people who need to transition from Excel and Microsoft Word and Outlook?
Yeah, so I think the stuff that I'm thinking about with like the crazy hardware idea is really just taking the tuning numbers that we already operate with, right? They already exist in the game. And at the very least, it just makes that iteration time basically zero. So you're like, okay, what if the AI shoots twice as fast? Like, twice as fast, as opposed to closing Pi, changing the number, saving it, opening Pi, and doing it. So I think for stuff like that, I don't actually see there being a big conceptual gap. I think if you want to get to the level where you're actually tuning while someone else is playing, like that maybe is a little far-fetched. And the metaphor kind of breaks down a little bit because some of the things you would be tuning wouldn't necessarily make sense to tune actually in real time, or if you're talking about a cooldown on the grenade from like 10 seconds to 8 seconds. But at the same time, like I kind of had an idea of how I might use that, and I think if you're playing with someone else, you might find that you might just want to start fucking with them, right? And as they start killing the AI, you like make it harder, or you like do something weird. And I think there's a lot of kind of cool discovery that could happen there where you might think, oh, hey, actually, you know what? It's pretty fun if after 3 guys die, we beef up those other 2 guys. So.
Thanks.
Awesome.
I'll try to remind you.
This is pretty. Does it work? Yeah.
Oh, wait
I
a
turned it
sec.
off. Sorry.
No, I'll take the time. Does it work?
Here, can you hear me? Yes.
Yeah, there we go.
It's pretty important what you just talked about. So I hope we can make this happen.